Thanks for coming to the YouTube channel, Mr. Professor, or 교수 아재 in Korean. In this video, we're going to handle some mathematics problem in 2024 Korean SAT. Suppose that a cubic polynomial satisfies the following conditions. So from the first condition, you may guess that the graph looks like this or this. But from the second condition, you may guess that there is a certain interval that the polynomial is decreasing. So we may not take this graph, we may take this graph. Okay, so draw here. Okay, and from the second condition, because A is between n and m plus 1, so you can have f prime negative n is also negative n here. So from the third condition, we can say that for each integer k, fk minus 1 times fk plus 1 is greater than equal to 0. So if we investigate f minus n, okay, so if f minus n is positive, okay, then because of this condition, f minus n minus 2 is also greater than equal to 0. And similarly, f minus n minus 4 is also greater than equal to 0. So you can keep going like this. Okay, but look at the picture of the graph. Okay, so as x approaches negative infinity, fx goes to negative infinity, which means that for certain values of the x, okay, fx is always negative. So this cannot happen. Okay, and similarly, if f minus n is negative, then you can say f negative n plus 2 is also greater than equal to, less than equal to 0. And f negative n plus 4 is also less than equal to 0. However, look at this. As x approaches infinity, fx goes to infinity, which means that for certain value of the x, okay, that's always a positive. So this also cannot happen. So we may assume that f negative n is equal to 0. So fx has a factor x plus n, like this. Okay, so we can draw like this. So here is a negative n, and here. So we may also investigate x is equal to negative n plus 1 and negative n minus 1. So if f negative n plus 1 is less than, which is negative, then you can also say f minus n plus 3 is also less than equal to 0 because of the third condition. Okay, you can keep going. So this cannot happen also, which means that f negative n plus 1 is greater than equal to 0. Okay. And similarly, f negative n minus 1, if f negative n minus 1 is positive, okay, then what happens? Then you can also say negative n minus 3 is also greater than equal to 0, and they keep going. So this also cannot happen. So we can have f negative n minus 1 is also less than equal to 0 here. So we have a picture like this. This is negative n. So here is the negative n plus 1. And here is the negative n minus 1 in here. Okay. And if both f negative n plus 1 is positive and f negative n minus 1 is negative, Then, so here and here, then this is a positive and this is negative, then we have a trouble. So this violates the condition 3, okay? So we cannot have this situation. This cannot happen. So which means that one of them must be 0. So f negative n plus 1 is equal to 0, or f negative n minus 1 is equal to 0. Okay, so that means fx has a factor, possibly x plus n minus 1, and we don't know what else. Okay, so say x minus a, and or fx is equal to x plus n plus 1, and we don't know last factor. Okay, so in this case, okay, yeah, so by using the second condition, f prime negative a is equal to negative a. So yes, so we can determine actually a or b. So by plugging the number alpha into x, well, actually we can determine the y value f alpha. Okay, so like the problem in Korean SAT, okay, we may assume that n is equal to 0, okay, and a is equal to a quarter. Okay, then let's see what happened. So this can be replaced like fx is equal to x times x minus 1 and x minus a. So you can compute this one. So this is equal to x cubed minus a plus 1 x squared and plus ax in here. So if you differentiate this one, then you will have a 3x squared minus 2a plus 1x and plus a in here. Okay, so by plugging negative a quarter in here, so we know by the condition 2, so negative a quarter is equal to f prime minus a quarter. So by plugging here, you will have a 3 over 16 and minus, so do you have 1 over 2, a plus 1 and plus a. So if you compute this one, then 3 over 2a and plus 8 over 16, so 11 over 16. So from here, you can have 3 over 2a is equal to negative 16 over 15. So we can have a is equal to negative 5 over 8 in here. So if you plug in here, then you can have x times x minus 1 and x plus 5 over a in here. So then, so it looks like, so in this case, this is 0, and this is 1, and this is negative 5 over a. So it's okay. So we have no problem, okay? And now from here, if you compute, so from here, fx is equal to x and x plus 1, x minus b, this is x cubed, and minus and b minus 1 x squared and minus bx. So if you differentiate this one, then you will have 3x squared minus 2b minus 1x and minus b. So if you plug one minus negative 1 quarter in here, that is negative a quarter again, and plus negative a quarter. So plug in here, 3 over 16, and plus 1 over 2, b minus 1 minus b. If you compute this one, then you will have negative help in here, minus 16, 8, so that's 5. So from here, we have 1 over 2b is equal to negative 1 over 16. So b is equal to negative 1 over 8. But from here, so this one looks like this is 0 and this is negative 1. So b must be positive, so we have negative here. So this is a contradiction. So we cannot have the situation. So the answer just looks like this. And then if you want to know the f alpha, so just plug the alpha in here. Maybe alpha is equal to 2 or alpha is equal to 8. You can just plug the numbers in here and you can determine the value. Thank you for watching.